Welcome to the super spectacular 7.1 lesson.
Wow.
New chapter. Moving into proportions. A lot of proportion work. So today it's just kind of a review over what a ratio is, what a proportion is, how do we solve proportions, good stuff. You learned this probably like way back in like 6th grade. All right. Warm up is to write down something you learned in chapter 6. And I know there's a lot of things that were awesome. So anybody want to share what they put? Lauren.
It's rhombi, not rhombuses.
I love that. The plural version of rhombus is rhombi. Good. Not rhombuses, even though rhombuses is more fun to say. So it's like, I also say funner sometimes because it's funner to say. Okay, anybody else? Ben.
A square is like a rectangle and a rhombus combined.
Yes, I like it. Squares are so fun. Okay, good. Good things. Quadrilaterals. Big family. Great stuff. All right. Today, first fraction work. As we know, just kidding. There is a lot of simplifying fractions. Well, simplifying like ratios in this unit. So let's just quick go over how you simplify, multiply, and divide fractions. Okay. Don't worry, we won't do adding and subtracting. When you simplify a fraction, you're really looking for the GCF, greatest common factor, of the numerator and the denominator. What is a factor? When we say factor in math, what even is that? Alejandro?
Something can be divided by.
Yes. Something that the number can be divided by. So if I say like the factors of 12, numbers that can be divided evenly by 12 would be like 1 and 12 are a factor pair. 2 and 6, 3 and 4. So 1, 2, 3, 4, 6, and 12 are all those factors, okay? All right, so looking at my numerator here, 28 and 63. What is the biggest factor that both of those numbers have in common?
7.
7. Nice. So you can divide out a factor of 7 out of both of these. 28 divided by 7 is 4. 63 divided by 7 is 9. This would reduce to 4 nines. Now, really, I don't know how you learn to like show your work. I know a lot of you guys can do this in your head, but you're just trying to find a common factor. And I'm not doing a prime factorization. I'm not breaking these numbers down completely, but I'm trying to find a common one that can be canceled out of my numerator and denominator. Okay. 77 and 44, GCF. 11. Good. So you can divide out 11 out of both of these. This one's a good example. I want you to leave your fractions as improper fractions. We don't really use mixed numbers when we are talking about ratios and all that good stuff. So get in the habit of leaving in an improper fraction. And that's good just like moving forward in your future math classes. 13 and 65, GCF. There's one. Well, 13's prime.
1.
Which means the only factors are 1 and 13. What does 13 go into 65? It does. Yeah. 65 divided by 13. Walker, what does our calculator say?
I messed that up. 5.
Goes in there 5 times. 5 times 13 is 65. Okay. Who can explain to us how we multiply fractions together? William?
The numerator by the denominator by the number. Or is it numerator times? Okay.
Yep.
So we're doing chemistry.
And we're going to do that when we get to proportions. And this is why I put this in here, because it's a very common confusion between proportions and multiplying fractions. When we're multiplying fractions, we multiply the numerators and multiply the denominators. Okay? The one you're thinking of this, cross multiplying, we're going to do that in like 30 seconds. Not 30 seconds. 20 minutes. Okay. You multiply straight across when you're multiplying fractions, okay? Cross multiplies when we have a proportion. Just out of curiosity, so here we could do this. You get 24 over 75. And then you'd have to reduce this, which they can both be divided by 3. And you get 8/25. Just out of curiosity, we're going to view kind of like taught to simplify before you multiply, like look for common factors within the numerator and denominator. I kind of like doing that. So here I'm like kind of looking at my factors in my numerator, my factors in my denominator. I'm like, ooh, 3 and 15. I could cancel out the common factor of 3, so that'd be 1 and that'd be 5. And yeah, I have 5s here, but they have to be common in the numerator and denominator. That's how they cancel, right? And then once you kind of do all the simplifying there, then you can just multiply straight across and get your 8, get your 25, and then usually, if you do it correctly, you don't have to simplify it anymore. That's another way you could do it. Okay. So this one, there's nothing common within the numerator and denominator, so all I can do is just multiply straight across. That'd be 8/15. Here I see, 3 in the numerator, 9 in the denominator, common factor of 3. Ooh, 8 and 4 as well. Those have a GCF of 4, so I can do this and get 2/3 right off the bat just by simplifying before you multiply. Okay, so what we need to remember is to multiply fractions, you multiply straight across. Numerator, numerator, denominator, denominator. What's an easy way to divide fractions? Alex? Multiply by reciprocal. Good. Have you guys ever heard the saying, keep, change, flip? Have you heard that? Good. Keep, change, flip. So, dividing by 1/5, whatever your divisor is, whatever the fraction you're dividing by, it's the same math as timesing by the reciprocal. And this just makes it a lot easier to do without a calculator. Okay. Your calculator will do 3/10 divided by 1/5 for you, but times by reciprocal, and then we see here, common factor. Multiply across, I get 3/2. Okay. Again, if you don't like the simplifying thing before, no problem. 3 times 5 is 15 over 10, and then you just have to reduce that. Okay. For sevenths, keep, change, flip is the same. If I want to divide 4/5 as times by 5/4. Here, I'm like, those 4s are common. That's the same as 5/7. Or 20 over 28, which reduces to 5/7. Okay, last one here. This one is kind of like what you guys did on the last test. A lot of you made this common mistake. Now, I know this was like in an equation setup. It was something like this, I think. And you had to divide both sides by 1/2, which a lot of you did. Like, you showed your work even. But then you told me 10 divided by half was 5, or something like this. I think it was 20, actually. But instead of dividing by half, that's the same math as timesing by 2. Timesing by the reciprocal. And I know that 10 times 2 is not 5. That should have been 20. Okay, so over here, keep, change, flip. 8/5. Again, leave it as improper fraction. Okay, there's just a little fraction review. Never hurts. But we will be simplifying ratios in this lesson. Okay, so a ratio is when you want to compare basically like two different things, such as like if I had like a bowl of fruit of apples and oranges, and I counted up the number of apples and the number of oranges. I was like, there's 10 apples to 5 of the oranges, like comparing the number of apples to the number of oranges in my basket, something like that. So you're just comparing two things together. There's a lot of different ways we notate ratios in math. Okay. Now, you just mentioned, I don't know how old you guys are. I don't know which ones of you are juniors, but ratios we just did for ACT prep show up a lot on the ACT. So they can be written, if I want to say a ratio of, I'm just going to say A to B, one thing to another thing, they can be written as like a semicolon that says a ratio of A to B. It can be written as a fraction, and that's more commonly how we write them in math, A to B. Those are all saying the same thing. They're giving you a relationship between two things, a comparison, probably a better word. That's what a ratio is. So all these different ways you can notate that. You always want to simplify your ratios unless stated otherwise. So if you write it as a fraction, obviously it's exactly the same as simplifying a fraction. So you always want to simplify the ratio if you can. All right. Let's do an example. Let's say the ratio of, I just did like virtual students to in-person. Now, obviously this number, like this year, we have a lot more people in person, but let's just say we had, for every 6 virtual students, 8 people were in person. So 6 to 8 was our ratio here, our comparison. Another way I could write this ratio, 6 to 8. 6 to 8 as a fraction, but we want to simplify this. So again, it's probably easiest to see this written as a fraction of how you could simplify that. So the simplified ratio here would be, they both could be divided by 2, 3 to 4, 3 to 4, 3 to 4. Those are equivalent ratios. They're very much just simplified. What's not equivalent to this is if I said the ratio like 4 to 3. That's different. The order matters. So 3 to 4 is not the same as 4 to 3. Think of it written as a fraction. 3/4 is not the same as 4/3, right? So those don't say the same thing. Okay, that's pretty much what a ratio is. We're just gonna do one. Oh no, we have a couple examples, a couple geometry examples, but here's a pretty like basic example that you've probably seen before. The number of students who participate in a sports program at Central High School is 520. And the total number of students at that school is 1,850. Holy smokes. Find the ratio of athletes to students. So a couple different ways we could write this. We're going to write it as a fraction because that's what we're going to need to do when we set up proportions. So the ratio of athletes to students. So think of your fraction bars almost like reading out loud as 2. So athletes to students would be how we want to write that ratio. We want to put our number of athletes on top and my number of students on bottom. All right, well, they tell me that my total number of athletes is 520. To my total number of students, 1,850. This one's a little bit bigger numbers to work with, but their only common factor is 10. So we do want to simplify this and write it as a ratio of 52 to 185. Athletes to students. Okay, B says, find the ratio of athletes to non-athletes. Ideas of how we could do this. Ooh, Matthew.
Take the number of total students and subtract the number of athletes.
Okay, we know there's 1,850 students in a school. We know that of those students, 520 are athletes. So that means the remaining 1,330 are non-athletes. Okay, so if I want to do athletes to non-athletes, I would do 520 to 1,330. Again, only common factor is 10. So simplify that ratio of 52 to 133. Okay, now let's apply some geometry to this. When I was doing ACT prep with the juniors, I think there was a problem exactly like this, like on the ACT. In triangle EFG, the ratio of the measures of the sides is 5 to 12 to 13, and the perimeter is 90 centimeters. Find the measure of each side. You can draw a picture if you want. You don't necessarily have to, but we know we have this triangle, and we know that the perimeter, which is all my sides added together, this length plus this length plus this length, is 90 centimeters. So if I know the ratio of the measures of the sides is 5 to 12 to 13, That means one of the side has to be like a multiple of 5, one has to be a multiple of 12, one has to be a multiple of 13. Okay? Doesn't matter which side you label what. So an easy way to algebraically do this is say, okay, well this side, if it's a ratio or a multiple of 5, it's going to be 5 times some factor. Okay, we'll figure out what this factor is. This side, say this is my 12 side, that's going to be some multiple of 12 or 12 times some, that same factor. And then my largest side, 13 times that same factor. So I don't exactly know to like which scale do I have this ratio, but I do know the perimeter is 90. So if I add up all those side lanes, 5x plus 12x plus 13x, I know that has to total 90 centimeters. So we can find kind of like that scale factor. That's 30x, and I add those all together, meaning x is 3. All right, so to find the measure of each side lane, so I'll start with this one. EF, I said, was 5 times 3, sounds 15 centimeters. 12 times 3, 36 centimeters. 13 times another 3 would be 39. Okay, so if you were to write these side lanes like as a ratio, and you were to simplify it, obviously you would get that 5 to 12 to 13. Now these might not always be nice whole numbers. Your scale could be like a fraction or a decimal, so just keep that in mind. But that's an easy way to solve that problem. It's just stick a variable on there and set up an equation. Okay, the next one's kind of similar. But this time, the ratio of the measures of the angles of a quadrilateral is 2 to 4 to 6 to 3. Find the measures of each angle of the quadrilateral. All right, so again, I'm going to draw a picture, even though that's not super necessary, but any four-sided polygon you want. The ratio of the measures of the angles is 2 times some factor, 4 times some factor, 6 times some factor, 3 times some factor. They don't give any totals here, but we know from chapter 6, what do the interior angles of a quadrilateral add up to? 360. 2 ways you could do that. It's 2 triangles, 180 plus 180. Or that handy dandy formula, take your number of sides minus 2 times 180. The interior angle should add up to 360. The sum of all these angles, so we'd add them up, the sum of all those interior angles have to add up to 360. Okay, so we can solve for x here, so that's 15x equals 360. X is 24. So it's kind of like your scale factor here. So just like before, to find the measure of each angle, start with 2 times 24, 48 degrees. Be this angle. 4 times 24, 96 degrees. This angle. 6 times 24, 144 degrees. Okay, this one. Doesn't matter how you list these. You want to do like smallest to biggest or biggest to smallest. I'm just kind of going in the order of that ratio that was given to me, 72 degrees. Okay. Here's an example of how ratios are used in geometry. And there's a lot of ratio and proportional reasoning on the ACT in many like different types of problems like geometry, trig ones, algebra ones. So this shows up a lot. Okay, so let's segue now into proportions. So proportion is just when you have 2 ratios that are the same, equal to each other, 2 equivalent ratios. So let's say I have a ratio of A to B, and it's the same as the ratio of C to D. There, now you have a proportion. So proportions are separated by equal signs. Just when you have a ratio, equal ratio. These proportions are when we cross multiply. Okay, that's kind of what this is saying right here. It's kind of worded weirdly, but cross multiply to solve these. We'll do some examples in a second. Oops, we'll spell solve wrong. And that's what we're basically showing you right here. If you have A to B ratio, which is the same as C to D, you could do A times D, cross multiply, and that will be the same as B times C. And you can solve from there. Okay, so we cross multiply when we have proportions, not when we're multiplying fractions. We're gonna do a couple algebra ones and then just a couple like context ones. All right, and number one here, I have a ratio 6 to x, which is the same as 21 to 31 and a half, is what that says, that proportion. So to cross multiply, you take the numerator of one fraction times the denominator of the fraction across from it, and it doesn't matter if you want to do 6 times 31 and a half, like on the left-hand side. I always like to do the variable ones on the left-hand side because I just personally like to solve when my variable's on the left-hand side. So I would do 21 times x first, and then I would do 6 times 31 and a half. All right. So this is a nice, quick, easy way that we can solve proportions, and as long as those two ratios are equal to each other, this statement here will be true. That 21 times that denominator will be the same as 6 times 31 and a half. Okay, and then you just solve the second normal equation. So 6 times 31 and a half is 189. Divide by 21. X is 9. All right, number 2. So I see my variables in the numerator here, so I'd probably set up negative 6 times x first on the left-hand side equals 11 times 4, which is 44. And then you divide both sides by negative 6. Okay, here's kind of my general rule. So obviously in your calculator, if you do 44 divided by negative 6 is going to give you this repeating decimal, which you probably know what that is. That's like a mixed number, but we don't really love mixed numbers, especially when we're talking about ratios. They can be represented as fractions, like you want to do improper fractions. All right, now your calculator can do this for you, and that's okay, because on the ACT too, you get to use your calculator on the whole thing. So it's smart to use your calculator to help save you time, so you got to know how to use it as well. So you can start practicing now how to use your calculator. You're going to hit the PRB. Above it, you see this little F to D. It means it'll change it from a fraction to a decimal. Now, it's always going to give you a mixed number first, unfortunately, but there's another button for that, and it's right below the PRB, so you got to hit second, and then that fraction button, and it'll change it to an improper fraction for you. I know it's kind of hard to see. My dot game sucks, but also, we just talked about reducing fractions, and if you write out your math like this, like think of that, 44 over negative 6, and just think about simplifying. That's every division problem is a fraction, right? So just reduce that, negative 22 thirds. Now I want you to keep it as a fraction when the decimal is repeating, for sure. And this is just kind of a good general rule of thumb in a lot of your future math classes. We want to keep it like an exact answer. So I'm okay with decimals if it's a decimal that ends, like 31.5. But if you have a repeating decimal, always, always, always leave it as a fraction. Okay, so specifically an improper fraction. All right, let's try a couple more. So here I see my variables in the denominator over here, so I'd probably do the multiplication negative 4 times 2y plus 5 first on the left-hand side. So that's the side with my variable, equals 6 times 7, which is 42. All right, now when you have a setup like this, put parentheses around it. So when you go to solve, you remember to distribute. And then this becomes a nice, easy equation to solve. Add over the 20, you get 62. Divided by negative 8. Here's what your calculator is going to tell you. That's fine, because that decimal ends. That's fine. And sometimes it just depends on the context of the problem, too. If it's like a word problem and decimals mean more sense, then you want to leave it as decimal. Or as an improper fraction, I'm okay with this answer too. What I don't want is a mixed number. Either of those answers are fine. But because this one's like not a repeating decimal because it ends, decimal is fine. Oh, I actually made a typo. You look like you have the same problem on number 4 as you do 3.
Yeah.
Sorry. Can you change it to this problem? I realized it as I was making copies that I like typed the same problem twice. So change it to this problem. I wanted to do one where you have variables in both ratios. You're like, ooh, I have a z in the denominator of my ratio on the left-hand side and a z on the denominator of the ratio of my right-hand side. So this one, it really doesn't matter. I'm going to do 9 times z minus 1 is the same as 7 times z plus 4. So again, doesn't matter if they're equal to each other. That's reflexive. What does matter, you got to distribute. And then we know how to solve equations with variables on both sides. We got to get all our variables together. So I would move over that 7z by subtracting it. So I'd have 2z minus 9 equals 28. Add over the 9, we get 37. Divide by 2. So here's another one. That's a decimal, which is 18.5. That's okay. Or you can just leave it as 37 halves. That's okay too. Okay. Now, normally, students are really good at, like, the algebra. Like, they know how to solve proportions. You do it in other classes. Lillian said they're doing that in chemistry right now. What they struggle with is taking a word problem and, like, setting up the proportion. Okay, and that's what a lot of the problems can be solved by, just setting up proportion on the ACT. So, we're just going to try a couple. Monique randomly surveyed 30 students from her class and found that 18 of those 30 had a pet, a dog or a cat. If there are 807 students in Monique's school, predict the total number of students with a dog or a cat. All right, so they're giving me a comparison of, in her class, of the 30 students, 18 have a pet. So there's actually 2 ways we could correctly write this ratio. We could say for every 30 students to 18 pets, or 18 pets to the 30 students. I think this makes a little bit more sense, but technically you could write it either way, okay? So if I say I have 18 pets to the total 30 students in her class, I'm putting pets in the numerator and the total students in the denominator. Could flip that. But when you go to set up the proportion, this is where it matters. So I want to predict the total number of students with a dog or cat in the school. So since I put my total number of students on the bottom, when I go to set up this proportion or the second ratio, I need to put the 870 in the bottom. And I don't know the number of pets. I'm trying to predict that, so that's where my variable goes. So you could also do this. If you want to put the total on top, you just have to be consistent in the proportion. That's what I'm saying, okay? As long as you get the same equation when you cross multiply, so you'll notice here, like we're going to do 30 times x equals 18 times 870, which I would get the same equation over there. As long as you get the same equation when you cross multiply, it doesn't matter how you set it up. They're both the same. Okay. So 18 times 870 is 15,660. Divided by 30. I'm predicting 522 students based upon what I surveyed in my small sample of students, making predictions about the entire population of the school. Now my answer makes sense. I mean, you could even go to, it's a little over like half of the people in the class have pets. So it should be a little bit over half of our total student body should have pets as well. You can even do percentages, all that good stuff, but we don't need to do that. One more. Mel fills his gas tank up with 16 gallons of gas for a cost of $26.58. That is expensive. How much would it cost to fill oops, that's a typo. That's how I'll say not and. I think you're saying 18-gallon tank. Okay. So we have this first relation that 16 gallons cost me $26.58. So if you want to write it as cost over gallon over cost, doesn't matter. I put cost on top as long as we're consistent. So the $26.58 to the 6 gallons that gave me, I'm going to put on bottom. All right, so to set my proportion, I want to know how much it would cost. My cost in the numerator. How much would it cost to fill up 18 gallons in my tank? Gallon goes on bottom. All right, cross multiply. 6 times x is the same as 18 times that 26. So here's what I'm talking about. Obviously, we're talking about cost. Decimals makes more sense, right? Especially if the problem itself gives you decimals, and usually your answer can be written as decimals as well. So that's that number divided by 6. I got $79.74. Okay. That's basically it. Just kind of a review over some basic math. Let me give you a